inside functions, right? So we have to look at lambda functions. This is one of the much talked about features in Python. So we will need to look at this, and then we have to also look at map, reduce, and filter functions. So let's get started. These are small little concepts, but then these are going to be very helpful for you. And these are much sought after or looked after or talked about features in uh, Python. So I will s- get started with the same Python notebook, which is functions.ipynb. And what we are going to do is we are going to look at the next one, which is we're going to look at the next one, which is the lambda functions. So I think Rahul has just joined, and Rahul, we're just starting with the lambda function. We were just having a recap of what we did earlier and what we are going to do today, right? So let's look at the lambda functions to begin with. So lambda function is nothing but it is a user defined function. It is no different than any user defined function, right? This is what a lambda function is. Now, why this is so important is because of its usage, right? So the way we define it and the way its lifespan is uh, defined. So think of it this way. Lambda function is nothing but a user-defined function, but it does not have a name. So we will try to define this and we will try to actually see how it is different than any other user-defined functions. So yesterday, when you look at the code here, we had defined a few functions, right? So print list is a user-defined function. We had defined this. Now, there was a square 1 function that we had defined. This is also a user-defined function. Square 2 is another function. We defined it and this is called square 2, right? So all of these are user-defined functions. Function 3 is a user-defined function. Now, when we define a user-defined function, the first thing that we talked about yesterday was that any user-defined function needs to have a fixed signature. And what all were part of the signature, if you remember from our yesterday's discussion, a few things, right? The function name. The function name to begin with is one of the things which you need to actually take care of. So for a user-defined function, the function name itself is very important. This is what we have seen yesterday. But what happens in case of a lambda function is a lambda function does not have a name. It will have a parameter list and it will have a return value, but then it will not have a function name itself. And this is one difference between a normal user defined function and a lambda function. So the first thing that we will be actually defining here for a lambda function is just a minute. So what is a lambda function? So a lambda function. So it is the same as the first one. It is a user defined function, right? It is a user defined function. So this is the first characteristic that we will or that we have already known, right? The other thing that we need to know is it does not have a name. Now this is going to be interesting. It does not have a name. If it does not have a name, then how do we call it? Because to call a function, we have to write the name of the function and then close it with a opening and closing brackets, right? So when we call an input function, we write the name of the function, which is input, right? When we call the print function, we write the name of the function and then we call the function. This is how you call a normal regular function, be it a user defined function or a system defined function, right? when we were calling uh, when we were calling a square, we were calling square, which is a user defined function this way. Now, if it does not have a name, if it does not have a name, this name does not exist, then how do we call it, right? So we will see how do we call a lambda function. So the first thing is it is a user defined function. The second one is it does not have a name. Except for this, nothing changes, right? We will still pass parameter, right? So lambda function has parameters that we will pass. And depending on whether you want to return something or not, a lambda function can return value. Totally depends. So these two are very much same as a user defined function, same as user defined function, right? But then this, in this aspect, this is different, right? Different than a user defined function, right? So I think this is enough for our introduction. And what we can do is now we can actually get into defining a lambda function, right? So let me show you a distinction, right? When we do the distinction, it will become clear to you. And the distinction that we are going to do is by doing a side-by-side comparison. So let us first see how we have defined a function, right? So we have a square function, right? This is how we have defined the square function. So let me copy this and I will show this to you. So here what we are doing is we are defining a square function, right? The name of the function is square and it is taking one parameter, and what it is returning, what we will do is instead of printing, we will do return num into num, right? So this function is going to actually return the square of the number that you provided to it. Okay, so what we can do in order to call this function, we can actually write the name of the function, which is square, and then pass a number, right? So let's say we pass a number 6. So what is happening here? Here we are calling the function using the name of the function, right? And then we are passing the number 6, and in return, this function is returning you number into number, which is square of the number, and then we are getting 36. For 6, we are getting 36, which is a square of this. If you were to write the same function via a lambda function method, then this is going to look like this, right? I will first make it a little simple to you. The syntax, the part of the syntax will start with lambda. This is a keyword, right? We don't have a choice. Do not think that the name of the function is lambda. It's a keyword. So why are we using this keyword? When we use the keyword, basically what we are trying to do is we are trying to define a function which will not have a name. This function is not going to have a name. We're defining a function which will not have a name, right? So what is it that we are writing? Lambda a into a, right? So let's look at the syntax a little more and try to find out what is happening here. So this versus if I were to write a name of the function, right? I will need to specify a name a and return a into a. Both of these are going to be the same. Both of these, either you write this or you write this, they mean the same. So what does it mean, right? What does it mean? How are they different then? So let me try and explain this to you. So in the left half, what we will do is we will try to create a user defined function, and this is the best way to do a comparison. So this is a user defined function, and on the right side we will define a sorry lambda function. So here again we have already seen this, right? This is square, it is taking a number, and what we are doing is returning num into num, right? This is how the syntax was. If you write the same function using the lambda function, right, then we will not specify Then function name, we will specify this keyword lambda, and then we have to specify the parameter. So first I'm writing the syntax and then I will write the code itself. Here we will write the parameter, right? Look at it. We have the parameter here. And then colon, and then after that the return statement. So here we will write parameter. I'm just enclosing this in the bracket, and then we will specify the return value. So when we do this, then what is going to happen? Actually, after the keyword lambda, we are specifying what goes in here, right? This is parameter. This is parameter, and this is the return value. So if you think of it this way, right, what is happening is we are not specifying the name of the function, right? And we are specifying the parameter here. So what is the parameter here? The parameter is num. So we will write num. And then what is the return value? The return value is num into num, right? So we will specify num into num. And once we do this, then what we have defined is a lambda function. This is how it works. This is how it works. So is either you define this function or you define this function. They both will do the same thing. The only difference is that this function has a name. It has a name square, and this function does not have a name. It is a nameless function. It will not have a name, but it will do the same thing as the square function. Any questions you guys may have? Since this is a new concept altogether and you may not have seen this in any other programming language, you may have a question. So do let me know if you have any.
No, Manish, I'm good.
Okay, so all right, so syntactically, the only thing which is different is it does not have a name. If you get that correct, then you will not have any issues in here. And we will talk about as to why do we need to use a lambda function and when actually we should try and use them. So what is happening in this case is when you specify lambda a into a, for simplicity, let me change this to number num so that it becomes easy for you to uh, do a comparison, right? So what is happening? Either you write this or you write this. This is going to be no different, right? So I'm just removing this part because this is what I copied over from one above. But then here, when we were defining the function, then we were actually calling the function using its name. But you must be wondering if it this function does not have a name, right? The same function when using a lambda function, when we write the syntax using the lambda function syntax, then if this function does not have a name, then how can we call it? So to call it, what we can do is we can assign this to a variable, and let's look at it as to what happens when we do this. So we are defining a function, right? The syntax is different, and we are assigning this to a variable x. Now, when we print this variable, look at it, what this is printing. It says function lambda, which means x has a reference to this function which is not having any name. So using x, now we can call this lambda function, and this is what we are able to see. Let me call x, right, and pass a value 6 again, or you can pass any value, right? And then what is happening here? So 10 is being passed as the parameter, and what is being returned? 10 into 10. So after lambda, whatever you specify before colon, this becomes your this becomes your parameter, and whatever you specify after colon, this becomes your return value, and we have just seen that, right? So after lambda, right, after lambda, whatever you specify before colon, right, this becomes your parameter. So this becomes your parameter. This is what the function is going to take, and then whatever you specify after colon, after this becomes your return value. And this is what is happening here. So this function which has no name is taking one parameter and it is returning one value. And actually, if when you look at it, it is returning the square of the number which it is taking as parameter. So it was very simple, guys. The same ways. I mean, if you look at it, right, the only thing that you should look at it as the numbers before colon are parameters, and the number after the colon character is your return value. And that is how you should interpret your lambda function. So this is your a comma b, which means there are two parameters this function is taking now. And what it is actually returning, it is returning the multiplication of both of these numbers. So it is taking two numbers a and b, and it is returning a into b. Now, since the signature has changed now, right? How can we call it? Since it has two variables now, which it is taking as parameter, you'll need to specify both of these here. You'll need to specify both of these here, otherwise you will not be able to call it. So let's try and call it. Let's try and call it using a single variable and see what is happening. So when we have defined it, we have specified two parameters, but we are calling it with just one parameter. And it says lambda missing one required positional argument b. So it is able to substitute 2 for a, but it is not able to find another value which it can substitute for the variable b, and that is the reason it is not able to call it call this function. So again, we have seen all of these yesterday, and what we can do is we can call this using the using the correct signature, which is by specifying two parameters. So that is how you can actually define any set of lambda functions. Now you must be wondering, what is the benefit of defining a function which will not have a name, or why should we even uh, define a lambda function when we can actually define a user defined function? So the answer is very simple, guys. You can define either a user defined function, a regular one, or you can define a lambda function. The choice is yours, but the only distinction is, if you need to reuse a function, then it needs to have a name, and that ways you will need to define a user defined function. But if you define a lambda function, then the usage of it becomes a little limited. You cannot really use it outside of your program code. You can use it within the program code, but not outside of it. So a few things that you should remember when it comes to lambda functions is a lambda function is a temporary function, right? A lambda function is a temporary function, right? So let's say you need to do something which we want to repeat within the program, but not outside of the program, then you can define a lambda function. So lambda function is a temporary function. We already know that it does not have a name. And the other thing that you need to remember is a lambda function cannot be used or called outside of the program in which it is defined. So what does it mean? It means that if this is my program file, right? Functions.ipynb. Then I cannot call any lambda function which is defined here outside of this program file. Can I call square outside of this program file? Yes, you can call it. You can call it outside of this program file because you can specify this as part of the library. And this is how we actually import those functions, right? Uh, we have not seen many so far, but when we do pandas, when we do NumPy, when we do matplotlib, that is where you will actually see some of these in action, where we can actually call functions or modules which are defined outside of the program file. So square is something that we can call outside of this program file, but not this function because it does not have a name. It does not have a name. It can only be called through this variable x, and this the scope of this variable is not going to be outside of this program file. So you cannot call it outside of this program. So that is how we can actually define. So we have seen two lambda function examples, one in which you can pass one parameter, the other one is where you can pass two parameters, right? Let's look at it. Let's look at some of the other ones, right? Another example where you can actually do a little more, right? So let's say we want to define a lambda function where we want to pass two numbers, and then we want to return. We want the lambda function to return the bigger number of these two, the biggest number of these two, right? So how can we write that, right? You must be wondering what all we can do within a lambda function. Can we write a if statement? The answer is yes. You can write a if statement as well, and this is how we can write it. It's a little different if you look at it. The then part is before the if part. So the syntax is slightly different, right? If you look at the syntax, this is slightly different, right? Ideally, we write a comma b if this, then a, else we write b. This is how we write it, right? But here, if you look at it, there is no then part. If a greater than b, then there is no then part. We already have specified a, which is the then part prior to we starting if, right? And then we have else b. So what does it mean? It means that whatever you need to do when the condition is true, you write that before the condition itself. So in a sense, how is this syntax written? This syntax is written somewhat like this. But then this is not how you actually write it. I'm just showing this to you to explain this to you so that you become clear as to how this syntax is a little different. So how does it how does it work, right? It says I'm providing two values a comma b, a and b, and it is going to return me a, the first value, if a is greater than b, else it is going to return me b, right? So I hope it should be clear and should not be that there should not be any challenge whatsoever in terms of trying to interpret this because this is simple, right? This is simple. It's just that we have specified the then part before the if syntax, and this is how it is. So let's look at it and let's try and execute and see what is happening here, right? So there are two parameters, so we can call this using two parameters and let's see what the outcome is. So I'm specifying a positive number and a negative number, and let's see if it gives me the greater of the two values. So yes, it is giving me the greater of the two values. And let's say if I make both of these numbers positive, then also it is giving me the greater number. So you can use a if as well, but then it will need to be used a little differently. Now, in a sense, you may be wondering that is there a compulsion that you need to use a lambda function? The answer is no. Is this going to be mandatory? Can we not do without writing lambda functions? Yes, of course you can. It's totally your choice. All the user functions for that matter that we define, these are all our choices. If you really want to use a user defined function without a name because you do not want this to be repeated multiple times or being called multiple times outside of the program file, then there is no compulsion for you to actually write a lambda function. You will be equally good with a user defined function as well, where you define the user defined function with a name itself. So it is not at all compulsory for you to actually follow this. This is not at all compulsory. You will be good with this, which is a user defined function as well. The only thing with lambda functions is when you define a lambda function, then you make a little better use of these functions, and the program code that you write are more readable and they're more concise. That is the only difference, right? So writing this statement, which is a two-line statement, uh, right? This statement versus writing this statement. If you read through this, this one is more neater, easy to understand, versus this line of code, which conveys the same meaning, but then the only difference is that it has more lines of code, and then it is comparatively a little, uh, more difficult to understand, right? Here we have everything in a single line. Here we have everything in two lines. So the choice is yours, guys. I mean, if you're really puzzled as to there's a new concept as lambda functions and you really need to use them, it is totally your choice. If you can do without lambda functions, you can do without it. That is totally fine. Every time you define a function, if you want to define it with a name, that is totally fine. This program, just think of it this way, right? This line of code is more readable. That is it. It does not necessarily mean that this is going to execute faster, or this is going to fetch you more marks, or this is going to impress the interviewer if you use a lambda function instead of a user defined function. Nothing like that. At the end of the day, your program code is supposed to give specific outputs, right, for the input that you provide. And if you are able to do that, then totally fine. You do not necessarily need to use any specific concept for that matter. But for your understanding, you should definitely be thorough with these concepts, right? And the only thing which you need to really remember is that a lambda function has a limited scope and it does not have a name. The rest of it is all the same as a user defined function. So, all right, guys, do let me know if you have any questions with Lambda functions. If not, then I will move ahead with the rest of the functions. Do let me know.
No, no, no.
Okay, all right. So, one more example with the Lambda function, and then we will start with filter, map, and reduce. So, um, right. So, can we use a for loop inside or not? Is one more question that you may have, right? Inside a Lambda function. And yes, you can use a for loop there, but here also when you look at it, the syntax is going to be slightly different, right? How do we write a for? We write for I in A, and then we write the next line where we write the print statement, right? This is how we write it ideally. So ideally a print statement would be something like this, right? But when you look at this here, your print statement is before the for statement. Now, why is that so? It again follows the same, structure the way we followed for if. We have already discussed this. The then part comes before if, and this is what is happening here as well. Whatever we need to write inside the for loop comes before the for loop, and this is the only difference. The rest of it is the same. So what is happening here? We are defining a lambda function where we are sending a parameter, right? And what are we doing? For I in A, we are printing the values of I, which means looks like we are trying to pass a list, and then we are printing all the elements of the list, right? And this is what we are trying to do. So let's define the function and then let's call the function. So this is our list. It has values 1 to 5, 1, 2, 3, 4, 5, and this is what it is doing. It is taking this list as a parameter, as an input parameter, and then what is happening for I in A, which means every time I will have individual elements of the list, which is first time it will have 1, then 2, then 3, then 4, then 5, and here we are printing the value of I, print I, right? So simple, guys. We can do whatever number you.
Manish,
Yeah.
then why we are getting out 24 none, 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 and as a
So
list?
this is printing. This is not printing none because of the print statement because the print statement is actually printing you this, right? Why is it printing 5 times none? Is not something that I can think of, Gajendra, because there is just one print statement here, right? Which is printing these values. And I'm not even printing the value of x. So we will need to, let me check, do a little, yeah. So when you print the value of x, then actually now it is saying that x is a lambda function. And now none is gone. So I really don't think it should have printed none. I really don't know why it was showing up. The only print statement,
Yeah,
yeah, the only print statement that we had is this, and it is executing these 5 times. So
yeah.
that's
We should actually get this the list of items only.
yes. So this print, what I want to show you is this print statement is actually only printing these elements, and that none was, I really don't know why that was getting printed. It should not have. But the moment we remove print x, it does show you none. So one reason because of which it can happen is because since lambda function is a temporary function and the moment you are out of it, the scope of it gets over, and that ways um, you're not able to access the elements, and that is why it is showing none.
Can you write the print before the X and then try to read it?
Print before x. Oh, this
Yeah,
one.
yeah. No, no. Just print X and then the statement which we are trying to print.
Print and then what?
No, no, no. Here,
Where?
just remove the print from there
Mm-hmm.
and go to the initial starting line. Yeah, here. Just write print. No, don't enter. Just print
Mm-hmm.
and just back in start and one the statement just put it in the bracket.
X.
No, 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 X and then bracket 1, 2, 3, 4, 5. That statement put in that print statement.
Oh, okay. Oh, okay, okay. Got it. So what you're saying is put this inside the bracket.
Yes, 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 yes.
So it is again
Okay.
printing the same statement. And it has to do, it has something to do with the scope, right? And that's something that I can think of because the moment you're out of the out after executing the print statement, which is the lambda function, right? The scope of this variable is kind of getting over, and when accessed, it is actually printing none. But the only issue that I have is we are not printing this outside of this, right? We are only printing it inside of the for loop or inside of this lambda function. So I really don't know.
Mhm.
Could be this could be a bug with the version of Python that we are using. Some of these trivial things they kind of take care of in the later version, so it might be a bug with the compiler. I Since we are only executing print statement once, there's no reason for anything after 5 to get printed. Getting it?
Mhm.
Yeah.
Okay.
So
Can you do one thing or
sure. Tell me.
no, no, it's okay. So I just wanted to say for I in A. So instead of A, can we use like B and O?
Yeah, we can do whatever. So since this is the
Not here.
yeah,
At the in the list for I in and then change A to B.
we can do that, but then in that case, we will need to change this parameter as well, right? Because this is what is
Mhm.
being fed here. So they need
Okay.
to be the same, right? If you don't change it, then this is going to be a problem. Why is
Right.
there a problem? Name B is not defined, right? So what is the input that you received?
Got
You
it.
received the input in A. And
A,
what is it
right.
that you're trying to iterate? You're trying to iterate
B.
B. And B is not defined. right?
right.
If you want to use B, then you can use B, but then you need to take the input as B,
Mm.
right? So this is trivial for us to just ignore this because it is anyways not part of the output which we are trying to generate, right? This is an output which is getting generated of its own, so we can just leave this for now. All right,
Okay.
so let's look at the filter function, right? So there is a function, there is a system defined function which is called a filter function, right? This is the filter function, filter. Now this is what we can actually look at now. So what does this function do? So as a definition says, right, the filter function returns an integer where the items are filtered, or it returns not an integer, it returns an iterator, right, where the items are filtered through a function to test if the item is acceptable or not. So think of a filter, right, operation. What does happen when you filter something? So when you filter something, then things which are acceptable to you are segregated, and things which are not accepted to you get segregated separately, right? And this is exactly what can happen using a filter function as well. So what can happen in case of a filter? Let me take a whiteboard separately, and let me try and explain this to you, right? So there's a filter function, right? And what this filter function does is you can program it further. So a filter function. So what you can do is, let's say you have a bunch of numbers, right? So you have 3, you have 4, you have 7, you have 12, you have 15, 17, 20, 22, and 30. So all of these are numbers that you have. Now you want to filter, right? You want to filter. But what is it that you want to filter? Let's say you want to filter all the numbers. You want to filter all the numbers divisible by divisible by 3. You want to filter all the numbers divisible by 3. So what is it that you will be left with? When you look at all of these numbers one by one, 3 is divisible by 3, 4 is not, 7 is not, 12 is divisible by 3, 15 is divisible, 17, 20, 22, and 30. So this is the list that you get, which is divisible by 30, and this is the list that you get, which is not divisible by 30, right? So these are the two lists that you get. Now, how do we do this in Python? In Python, I should be able to use filter function, right, and program it in a manner that you pass it two things, right? You pass it one criteria, right, and you pass it a list. So you will pass two things to this, right? You will pass one criteria to this, and you will pass another list. So this is the list that you want to filter, right? And this is the criteria based on which you want to filter. So for filtering operation, there are two things that you need, right? You want the whole list, right, that you want to filter, and how do you want to filter? What is the criteria based on which you want to filter? So here, what was the list? This is what our list was. And what was the criteria? Our criteria was the number should be divisible by 3. And what did it give you? These are the numbers which fulfill the criteria, and these are the numbers which does not fulfill the criteria. So these are my when you call this, these are my filtered items, right? And these are my, when you refer to these are my filtered out items. So we do not need them, right? After the filter operation, these are going to be discarded and these are going to be selected. And this is how we are going to use the filter function, by specifying the criteria as well as the list itself. And let's look at it as to how we can use them. So what is happening here, right? We are first defining a list of items. And what are we doing? We're just generating a list of random numbers, right? These are all manually defined. And then what we're trying to do, we're trying to uh, define a lambda function, right? And just remember this part, right? Inside the filter function, we have to specify two things. The second parameter is going to be the list itself, and then the first parameter is going to be the criteria. So just let's look at this objectively and see what is happening here. So inside the filter function, there are two parameters. This is the first parameter, and this is the second parameter. The second parameter, like I said, is the list, right? So this is the list which we want to filter. And how do we want to filter it? For that, we have defined a lambda function, right? And what is happening here? First item that we have here is the parameter that we are receiving. So we are receiving x as a parameter. And what is it that we are trying to do? We are trying to do x% 2 is not equal to 0. So can anyone tell me what is happening here? What will happen in this case?
We just find out that divisible by two
So we're
number.
just trying to find out if this number, if
These are not divisible by two number.
these are, yeah, whether the number is not divisible by 2, right? So what are we trying to do? Are we trying to filter in uh, the odd numbers or filter in the even numbers? What are we trying to do here?
We are just trying to get the odd number.
Yes, exactly. So this filter function that we are trying to do here is not going to work on its own, right? Because the computer or the program will not know what is your filtering criteria. Your filtering criteria is something that you need to specify on your own. Unless and until you specify the filtering criteria, the program will not know what is your filtering criteria. And that is why you need to specify your criteria, right? We just saw this. So the first thing that we need to do is specify the criteria, right? This is the criteria, and then the second one is list. So in our criteria, what we are trying to do, we have defined a function which says whether the number is divisible by 0 or not. So all the numbers which are not divisible by 0, they are going to be filtered in. And the second one is a list itself, which is this list. So how this is going to work is this function is going to evaluate each and every item of the list. And actually at the end of the day is going to it is going to create a list, another list, right? It is going to create another list of all the items which are satisfying this condition, right? Where the x%2 is not equal to 0. So as the outcomes at the output of this function suggests, this is going to actually give you all the odd numbers, right, from this list. If I change the criteria to make it equal to 0, then this is only going to give me all the even numbers. So this is how you can actually use a filter operation. So what is the question
Uh,
here, right? Yeah, ask me.
Manish, we just write the final list equal to list. So, list is the keyword over there, or we can write anything over there.
So list is a way where you can actually define a function. List is a keyword, of course, but then what is happening here is this outcome, right? The whatever I've selected so far, the this line of code is going to return you multiple values, right? Whatever
Yeah,
numbers from this list satisfy this condition, this filter function is going to return you all of those values, which means that you will have more than one values. Possibly you may have more than one values being returned from this function, filter function, right?
right.
So what will you do with that list? What we are trying to do is when we enclose that inside list, then we are creating another list of those values which are being returned by the filter function. And that is
Yeah.
why when you print final list, when you look at this, it is all the three numbers are enclosed by a big brackets,
Bracket here. So,
which, yeah,
can we create a tuple over there? I
we
think
can,
it
we can,
should not, right?
yeah,
Because
you can,
tuple is not mutable.
Yes, you can create a tuple as well. It is totally fine. It totally depends on your need. You can create a set out of it. If you want to create a set, you can create a set as well.
So we just need to write set over there, right?
Yes, you can just write set, or you can just use tuple, and that will work as well.
Okay.
So there are a few things, right, which are happening here. This is a lambda function, which we are using to define our criteria, right? This lambda function is
Mm-hmm.
only actually defining the criteria for the filter function. Then there is the filter function itself, right? So here we have a lambda function, then we have a list. Now both of this we need to provide to the filter function. So here we have specified the filter function. And whatever outcome the filter function is giving you, that is what we are specifying inside a list. So when we do that, then the outcome of this is going to be created as a list, and that is what is happening here. Whatever outcome you are getting from here, this is being created as a list, and you can either create a list, or you can create a tuple, or you can create a set. You'll not be able to create a dictionary because you do not have a value,
Yeah.
key value
Right.
pair, but then you can create a set as well. Sure. All right.
Yeah.
So this is how you actually use a filter function. Now, again, this is not a compulsion for you to create use user defined a system defined or a predefined filter function. If you really want, and if you want, you can create a function of your own as well. You can use a user defined function for that. That you
So, Manish, is there any criteria or any live scenario like we where we have to use a lambda function like this?
so of course there are definitely scenarios, right, where we want to do something which we do not want to reuse, right? So let's say this example in here, or all of these examples that we have defined here, right?
Mm-hmm.
This is where you are just wanting to print a small statement, right? Again, this is where you want to add a number to another number, right? Think of it
Right.
this way, right? Everything that you can define can possibly become part of your own custom library, right? Now, when I say it can become possibly part of your library, which means that if you are defining a function, then there are two usage of it, right? Either you want to use that within the same program, or you want to make this available as part of the library so that you can use it in another program as well. Getting what I'm
Right.
saying, right?
Yeah.
But if you do not have any such usage where you want to use it in our other programs that you define later, or other programs that you write later, then you can define the same function as a lambda function. So that is one way. The other way is when the logic is such, when the logic is so easy that you really do not find a lot of value in actually. Just show you one example. What is happening in this case? So this example, right? The logic is such that, or logic is so simple. This is where you're using a if function, but then here you're not even using a if function, right? It is going to be a function where it is going to be a function where you have two parameters, and then you have a single statement returning both of these values. Now, this is a simple example where you want to maybe define it, use it, and not reuse it in any other program. Because there, if you
Mm-hmm.
want to reuse it, then you can either define it later in that program, or in that case, uh, you may look into any other libraries which are available for you to be able to do this separately. So if you really do not want to reuse this or add this as part of your library, then you can just leave this. You can just define uh, a lambda
Lambda.
function. Yeah. But if you want to really reuse it, think of any function, right? Think of a input function. How are you able to use it? You are able to use it because it is definitely not defined as a lambda function. You're able to use print statement, or you are able to use the list functions or len function, right, to find out the length of any list, right? How are you able to call them? You are able to call them because these are defined as a user defined function and not as a lambda function. But
Mm-hmm.
whenever you want to, let's say you are writing a piece of program where you want to define a function which we do not want to reuse later, then you want to still reuse it, right? The only reason you want to write a function and not a statement is because you want to reuse the code. But if you want to not reuse the code outside of this program file, then you can define this as a lambda function. That is how it is governed.
Okay.
Yeah. So here, why did we define a lambda function, right? Inside the filter function, what is it that we're trying to do? We're trying to find whether the number is odd or even, right? But
Yeah.
we could have done this by defining another function as well. It
Yeah.
is,
So
it
here
is,
we call that function and then
yes,
it will work, right?
we could have called that function instead of defining the lambda function here. But the requirement was so easy that we did not want to reuse this. We actually defined it this way, that we defined it here and then we did not want to call it later on. Okay.
Yeah.
Yeah. Okay. All right. So let's move on to the next one, which is the map function. So there are two different functions. In fact, total three. We have already covered one, filter. And there are two other functions that we may be interested in looking at, and let's look at them right now. So there is a map function, right? What does the map function do? So map function is used to perform the same set of operations onto any other uh, all the elements of a list, right? Or all the elements of any object for that matter. So I'll give you one example, right? So what happens is uh, for all of these, the filter function, the map function, or the reduce function, these are all predefined functions, and you do not necessarily need to absolutely use it. You can define your own functions for these functions. The thing is that these are predefined ones, and if you really want to use them in its present form, you can use them as well, and that is totally fine. So how can you make use of the map function? So what happens is, let's say you have a list, right? Let's say you have a list. You have a list, right? You have a list. This is the list that you have, and you want to perform some set of operation on the whole list, right? So your requirement is that you want to perform an operation on the whole list, right? And this is going to be different than filter. So in filter, what was you doing, right? You were trying to, based on a criteria, filter in a few things and filter out the rest of them based on whether the condition was satisfied or not. This was a different problem altogether. Here, what we are trying to do is we want to perform an operation on the whole list, right? Now, what that operation could be? This operation could be plus 5. This operation could be into 2. This operation could be square, right? This operation could be square root. This operation could be cube root, right? It could be anything. It could be uh, divide by 10. It could be anything, right? But then the thing is that you want to perform a same operation on all the elements. So if you want to add 5, then you want to add 5 to all the elements of the list. If you want to multiply 2, then you want to multiply 2 with all the elements of the uh, of the of the list, right? And this is where the map function will help you. If you really want to perform one single operation on all the items of the list, then you can make use of the map function. So let's quickly see as to how map works. And again, same as how we were, if you look at the syntax, right? We are again at the end of the day creating a list, another list, and then instead of the filter function, we are using a map function. And here we are defining again a lambda function, and the map function is having two parameters. The first one is the criteria or the operation that we want to perform, and the second one is a list. So if you want to really compare it with what is happening or what is similar between a map and a filter function, here also in the map function we are specifying what is the operation that we want to perform and what is the list on which you want to perform the operation. And then all of this we are enclosing within the list. So whatever happens here, all of the
Criteria
elements.
and list.
Yes. So instead of the criteria, here we have a operation, right? Because we want to perform some kind of a operation on the whole list. And that is
Yes.
what we are trying to do, right? So uh, here the operation that we are trying to do is we are multiplying this number with 2, and the rest of it is exactly similar. It is having no difference as such. The only difference is the name of the function that we are using here is map. So what are we trying to do? We are trying to actually multiply this all of these numbers with 2, and that is what is happening here. So if you look at it, the first number 5 becomes 10, 7 becomes 14, 22 becomes 44, and this is the easiest way using which you can actually do a same set of operation on the whole of the list. So why this is helpful is because if you look at it, there is no for loop that we have tried to do, right? You have not performed any for loop to multiply each of the elements of the list with 2. We have used a map function. And actually, if you ask me whether you could have used the other method, the answer is absolutely fine. Yes, you could have used the other method as well. Instead of the map function, the other way to do this is you could have used a for loop to iterate through the list, and every time you could have multiplied the list with the uh, value of the item in the list into 2. You could have done that as well. That would have been totally fine as well. There is absolutely no problem there with that approach. You can do that as well. So fine guys, this is map. I'm just reiterating since these are not user defined functions, these are system defined functions. Filter is what we were trying to use to filter out or do some filtering operation on a list, right? And this way, the list itself was getting reduced. It was getting smaller. But in case of a map operation, your list is not going to get reduced. The number of elements are going to be the same. It's just that we are performing any kind of a operation on all the elements of the list. So when we do x multiplication 2, then actually we are trying to do a square operation on all the elements. You can same ways do divide by 2, and this is going to give you half of all the elements of the list in the new list. So I'm just going to leave this to square and let you guys run this so that you can actually know what is happening here. The next one, this is somewhat interesting, right? And let me show you what the third one does. Here, what we are trying to do is we are trying to do a reduce operation. So this is interesting, and I will actually need to show you as to how this works so that you can actually understand this. So let's say I am given a problem, right, where I need to uh, add a lot of numbers, right? I'm given a problem where I need to add a lot of numbers. So let's say the numbers, let me start a fresh page. Yeah. So let's see how you will solve this, right? So the problem that I'm given is I'm given a lot of numbers. I'm given 12, I'm given 15, I'm given 20, 10, 13, 16, 25, 35, 40, 21, 26. So all of these are numbers, right? I'm given these numbers and I have to add them all. Now, how can I add all of these, right? Is the problem. One way is I can do this plus this plus this plus this. plus this, plus this, plus this, plus this, plus this, plus this. The now one may ask, right? And whatever you get out of at the end of it, right? Whatever value you get is the correct sum. This is a correct approach. There is no problem as such, right? This way also you can get the output. What if, how many numbers you had so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you had 11 numbers, right? So you could have easily written it like this. What if you had 100 numbers and you had to add all of them? You will need to change the whole statement, right? The statement that you're running. Or maybe you will need to, if you are running a for loop for I in range 1 to 11, right? If this is a statement, you would have to change this, right? You have to change this from 1 to 11 to 1 to 100, right? Sorry, this is 100. So you need to change this slightly. Wait. Yeah, so you will need to actually change this statement here, right? And let's say instead of 1,000 numbers, you have a million numbers, 1 million numbers to add. What will you do? You'll again come back and change this part, right? Now there is something called as a reduce function using which we can do this really smartly, and we will just see as to where the term reduce comes into picture. So can you all agree with me when I say that this is whatever number, whatever set of numbers you have here, this is a addition of two numbers, and we need to do this multiple times. The simplest problem that we have here is that we need to add two numbers, and then we got to do it multiple times. So I'll tell you what do I mean. What I mean is, can I think of it this way, that we can add the two numbers, right? So 12 and 15, right? What did we get? We got 27. And then we got to do this with the rest of the numbers repeatedly. Now, instead of these two numbers, what we have got is 27. So now do the same, 27 plus 20. What did we get? We got
47.
47, right? So instead of this and this, now we have 47. Now can we do the same with 47 and 10? So we got
Yeah.
57, and we remove these two, get rid of these two, right? Now we can do the same here, 57 and 13, so we have 70,
70.
and now we can actually get rid of these two. So if we continue doing this till the end of the list, what are we reduced with, or what are we reduced to? We are reduced to the
Numbers.
sum of all the numbers, right? And this is what we wanted, and we really do not need to keep a track of how many numbers we have in the list. We can keep moving or keep doing this addition of two numbers till we reach the end of the list. This is what we want. And this is what reduce does actually. So a reduce function, if you look at the syntax now, a reduce function is having one operation, right? It will have one operation. And what is the operation that we are trying to do here? We are defining a lambda function which is taking two values, right? X and Y, right? And what is it that is doing? It is adding these numbers, right? And we are specifying a list as a second parameter. So what is it that the reduce function is doing here, right? The reduce function is actually first calling this lambda function with 5 and 8, right? And what is it that it is giving you? It is giving you 5 plus 8, 13, right? Now, what does the list become now? So the list, which is 5, 8, 10, 20, 50, and 100 becomes, I'm so sorry. So this list now becomes 13, 10, 20, 50, and 100. Now this lambda function, this reduce function is going to get called again with the first two elements of the list, right? Which means it is now going to get called using these two, and the list is going to get reduced to 23, 20, 50, and 100. Now this is going to call it using these two, so 43, 50, and 100. Now this is going to get called using 43 and 53, 43 and 50, which means 93 and 100. And then this is going to get called using 93 and 100. And finally, your list is reduced into a single item list. And this is what you were actually looking to do to begin with. You want to add up these numbers, and at the end of the list, you will have the sum of all of these items. And this is what is happening here. So when I run this, what is happening is I'm getting 193. Now, how am I getting 193 is because my list is getting reduced every time by adding the first two elements of the list and replacing that with the sum of the list, sum of these two items. Getting it, or you guys have any confusion with the reduce function?
No, Manish, I'm good. Just one question.
Hmm.
Can we use multiple operations within the same lambda function?
We can, but then there are these restrictions, right? I mean, you can use not more than two, and that is where the lambda function actually becomes a little restrictive. It is actually very good or beneficial when you actually need to perform either one statement or very little statements that we need to define within a lambda function. Even the syntax and the problem uh, we have already seen earlier is that the syntax for if and for, they are not the same. And what do you think that's the reason behind this? The reason behind the syntax being a little different is because ideally we are supposed to write a one line statement or a single line statement as an outcome for the lambda function, because it primarily has the parameters and then straight away it has the return values. You do not have a lot of manipulations that goes behind the lambda function. So wherever you see a lambda function, rest assured that you will not see a lot of lambda functions which are really big in terms of code, or in
Mm-hmm.
terms of the lines of code that you specify there. It will not be the case. So you are allowed to write multi-line statements, but then all of these statements are also very tightly governed as to what you can actually do. So think of it this way, right? This is a two-line statement or multiple line statement. So this is one line, this is two lines, right? Second line, this is
Mm-hmm.
the third line, and this is the fourth line. But then it does not necessarily mean that you can write this statement in four lines. Getting what I'm saying?
Mm, yeah.
This is also two lines of code, right? For I in B and then print I. But then it does not necessarily mean that you can write this statement in two lines. So they have changed the syntax for the Lambda function in a manner that you're able to write multiple lines of code within a single line, but then ideally it supports a single line of code only.
Yeah. So I just wanted to know, like, in the reduce function, we are just doing the sum, right? So
Yeah.
instead of the sum, can we do first check or if the number is divisible by two or not, and then we do sum it?
Yes, you can do that. You can do that because because for that you need if, right? And if is supported inside a lambda function, so you can do that. That is not going to be a problem.
Okay.
You can do that. And actually, when it comes to reduce function in uh, big data platforms, right? Primarily Hadoop. You must have heard about reduce function there, right? So what happens there, right? This reduce function actually is mimicking exactly what happens in Hadoop when it comes to reduce function. So I'll just quickly give you guys a little uh, idea about how this is similar to the reduce in Hadoop, and then probably we can call it a day after that. So what happens in case of a why do we use Hadoop, right? We use Hadoop in case of a big data problem, right? When you
Yeah.
have
Big data
many
problem.
when you have many when the volume of the data is such that it becomes a big data problem, you cannot actually process that volume of data using your regular computers. You need a big data architecture
cluster.
solution to be able to do that, right? So what happens in that case? Let's say you have many numbers to add, right? You have many numbers to add. So what do you do? Let's say you have these many numbers to add, right? You have these many numbers to add. I'm just using a pictorial representation, right? So that it becomes easier for you. So let's say you have these many numbers to add, right? This bucket has many numbers. So what you do? You actually divide this set of numbers into multiple
Mm, chunks.
blocks, right? Or chunks, you can say, right? So this is my first block, this is my second block, third block, fourth block, fifth block, and sixth block. And then what you do is you assign all of these problems, small problems, to individual computers, right? So what are you trying to do? You're trying to reduce the problem into smaller problems. So these are my small blocks of or clusters of computers, right? So you ask the first computer to add all of these numbers, which are part of this set, and then you do the same thing with the rest of the numbers as well. So what will happen at the end of the day, right? At the end of the day, all these numbers, the sum of these numbers are going to be given by your first computer. The sum of all the numbers which are part of the second set, right, are going to be given by the second numbers. So what will happen in this case is you may have, let's say, 100 numbers each. These are 100 numbers each, but at the end of the day you only will have six numbers that you will need to worry about. So we will have the first of 100, the sum of first 100 numbers as one number given by the first computer, the sum of the second 100 numbers given as another number available to you by the second computer, and that ways you will have only six numbers to deal with, and then you can actually add them all to get the outcome. So that ways what will happen, there are two ways, two things which are happening here, right? Your problem is becoming smaller because you have six computers to do all of these stuff, right? So you can actually reduce this problem into smaller problems. And then at the end of the day, one master computer or one master node can actually add all of these numbers, all the numbers which are given by your six blocks. And this is the same concept which is applied there, right? Which is what is happening here. You can think of this way as well, right? So this is my first set of computer which is giving me some outcome, and then this is my second computer which is giving me some outcome which is coming here. Now third node which is actually giving me one outcome which is being used by the fourth one which is giving me some outcome, and then this outcome is being used by the fifth one. And that ways when you divide this problem getting reduced from a five digit, one two three four five six, a six digit or a six numbers to add, to five numbers to add, to four numbers to add, to three, to two, and then you're left with just one number, and then you do not need to do any operation. So ideally, in a big data problem, this is how the map and then the reduce functions, they are used to perform multiple operations on a list, or if you really want to do any operation and aggregate these numbers, then reduce is actually used. So if you want to do a same set of operation onto the whole list, then you use a map function, otherwise you use a reduce function. So that is how it is. There's another example which I have kind of added here, but then I'm not going to discuss this. I'll leave it on you guys
कटेगा.
to actually look at it. One thing that you need to actually understand here is and take a note of is that if you look at the filter function, we did not import any library because this is part of the basic packages. In case of a map function, we also did not import any library. This is part of the basic package. But if you really want to use reduce, then you need to import reduce, right? And how do you do that? From function tools, import reduce, and that's the only way when you can actually use it, otherwise it'll give you an error. So if we have already imported this, that is why it is not giving me an error right now. But if you do not import, or if you do not include this statement, and if you just run reduce, then it is going to give you an error, right? You can change the symbol as well, and if you want, you can change this to anything that you want, right? Okay, so guys, I think this is what it is for today. I hope you enjoyed the session today and learned something new.